All right, I would like to explain how to solve the equation sine of theta equals negative 1/2, and then use periodicity and symmetry to find multiple solutions. Okay, so the first thing we want to do is just solve this algebraically. And so we're solving for the angle theta, and to get the theta by itself, we need to undo the sine. So let's take the inverse sine of both sides. When we take the inverse sine of both sides of the equation, that leads us to the inverse sine of theta. And then the inverse sine and the sine undo each other, leaving us with just the theta. And then the inverse sine of negative 1/2, I'm just going to type that into the calculator, negative 1/2, I get a value of negative 30. That's exactly negative 30 degrees. Now, what does negative 30 degrees look like? Negative 30 degrees, we know that all angles when graphed in a coordinate setting, 0 degrees is right there, and we know that positive angles rotate counterclockwise, like that. And so if we have a negative angle, that means that it rotates clockwise 30 degrees, about like that. So negative 30 degrees is going to look like this. This rotation is negative 30 degrees. Okay, so that is one solution, and that is called the principal value. Principal meaning first. So this is the first solution, but there are many other solutions. And we're going to use periodicity and symmetry to find every other solution. So one of the first things to know is that whenever you use a calculator to find inverse sine, only inverse sine. It doesn't work for inverse cosine. But for inverse sine, the principal value will always be a value on the right side of your circle, the right side. So what you then want to do is find values on the left side and then use periodicity to find other values on the right side. So periodicity, I think, is easiest to understand, so I'm going to do that first. Now, I'm going to kind of divide up solutions here so that we have solutions. I'll put them in red. Solutions on the right, and then in green I'll have solutions on the left. Okay, so our principal solution, our principal value is negative 30 degrees. Let's find some more using periodicity. Okay, so we have negative 30. Well, what is the period of sine? The period of sine is how long it takes to make a complete cycle, and it takes 360 degrees to get back to where we started and make a complete cycle. So if we add 360 degrees to our principal value, we'll get another solution. So let's do that. If we add 360 degrees, we get 330 degrees. And we can check to see if we're right. We can check to make sure that's a solution. First, let's do the sine of negative 30 degrees. And notice that we got the negative 1/2 from up here. And let's now do the sine of 330 degrees. And notice that we get the same ratio, negative 1/2. And we could keep adding 360 degrees. I'm going to add it a couple times. So let's see, that's 690. Let's see, this is 1050. And then this is going to be 1410. I'm going to check all those just to be sure and just to show that they all have the same sign. Boom. All of those are solutions. So I'm just going to add these to my list of solutions on the right side. So I've got negative 30 as a solution. I've got 330 degrees as a solution. 690 degrees as a solution. 1050 degrees. 1410 degrees. How many more solutions are there? Well, there's going to be an infinite number, so I'm going to put a dot, dot, dot. And I'm just going to put there is a new solution every 360 degrees thereafter. Okay. Now, what about before? Can't we rotate in the other direction? If we're adding 360 degrees, that is a counterclockwise rotation. This would be adding 360 degrees. If this is our initial solution and we add, this is negative 30, we start at 0, that's negative 30. And if we add a full rotation, we add a full 360 degrees, we're back to where we started, and this would be 330. Notice 30 degrees short of a full 360. Okay, but what if we subtract? So let's go back to the beginning. Here we go. Here's 0, and we're rotating negative 30 degrees. So 30 degrees in the clockwise direction. What if we then continue rotating in the clockwise direction? So again, that's negative, another 360 degrees. So another 360 degrees would take us back to there. And where is that? Well, instead of having negative 30 degrees plus 360, it would really be like negative 30 minus 360, because we're going in a minus direction, a negative direction. And so when we do that, we get negative 390. And to double check, we could do sine of negative 390, and we are going to get the same ratio. And we can keep doing that. We can keep subtracting 360. Let's see. And we still get the same ratios. So I'm just going to add those solutions onto our list of solutions on the right. Negative 390, negative 750, negative 1110. And we could have a dot, dot, dot. There's also going to be more solutions, negative every 360 degrees before that. Okay, so that is periodicity. Now we need to understand symmetry. So for symmetry, we need to understand the definition of sine, the extended definition of sine. The definition of sine, the extended definition of sine, is that the sine of any angle is equal to its y value divided by the value of the radius of this circle. So what other places in this circle share the same y value? All the values in the circle share the same radius, but what other places in this circle share the same y value? Well, the y value This point on the circle is located at x, comma, y. So the x-coordinate is this one. The y-coordinate would be this one. So what other points on the circle share this y-coordinate? Well, it'd be the one over here. I'm going to put that in green, which would come from this radius. This coordinate right here shares the same y value as that. So therefore, the sine of this angle over here will be the same as the sine of this angle over here. So where is that? Well, let's use the fact that this is a 30-degree angle. Now, how far is it from here to here? That's 90 degrees of rotation. What about from 0 to here? How far is that? That is 180 degrees of rotation. So I'm going to write 180 degrees of rotation from 0, 90, 180. And notice we're going in a positive direction here. Counterclockwise is positive. So how much farther do we need to go to get to this radius? Well, since it's symmetrical, the circle is symmetrical, since this is negative 30 degrees, meaning 30 degrees in the clockwise direction, we need to go 30 degrees in the counterclockwise direction. Counterclockwise is positive, so I'm going to, onto this 180, I'm going to go another 30 degrees. So altogether, what is the angle of rotation that starts here and ends at this radius? That would be 180 plus 30, which is 210 degrees, which would be a solution. Let's check it before we write it down. Sine of 210 degrees. Notice the same exact ratio, negative 1/2, negative 0.5. So I'm going to write that as a solution. Whoops, why did I put negative 210 degrees? It should be positive 210 degrees. Positive because we're rotating in the positive direction, the counterclockwise direction. All right, so that is the solution using symmetry. We have our principal value. I'm going to put a star next to this, the principal value. So when we solve equations like this on the calculator, we get a principal value, and then we can use symmetry and periodicity to find others. We use periodicity by adding 360 degrees to find all those solutions. We also use periodicity and subtract it 360 degrees to find other solutions. When we use symmetry, it gives us this solution, 210 degrees. And then once we have that, we can use periodicity with that 210 degrees to find others. So I could do 210 degrees. So let's see, we're at 0, 90, 180. That's 210 degrees. I could add another 360 degree rotation to that 210, and 210 plus 360 is 570. Let me just check the sine of 570. Look at that, exact same ratio. And I could keep adding 360 to this. 360 to this is going to be 930. 360 to that will be 1290. Let me just verify this. Same ratio. I could also subtract 360. 210 minus 360 is negative 150, and then the sine of negative 150 is the same. So negative 150 is a solution. If we subtract 360 from that, find again the sine of negative 510, the sine of negative 870. All of these have that same ratio of negative 1/2. So if you really want to show off some extra knowledge, you could also say, hey, wait a second. There is symmetry right here. So we have the symmetry of, let's say, 210. Let me put an A beside that. 210 right here is symmetrical to this, which is negative 30 degrees. But how much would it be on a positive side? Well, we have 0, 90, 180, 270, 360. Uh-oh, I went too far. How far did I go? Well, I went 30 degrees too far, and so if I go back from 360 minus 30 degrees, 360 minus 30, 360 minus 30 is 330, which is symmetrical. So 210 is symmetrical to 330. Similarly, 570 is symmetrical to 690. Let me show you. Let's count by 90s until we get to 570. 90, 180, 270, 360, 450, 540 plus 30 more is 570. If we keep going, let's see, 540 was right here. 540 plus 90 is 630. 630 plus 90 is 720. Uh-oh, I did it again. I went too far. I went too far by 30 degrees. So 720, that's 2 full rotations. 720 minus 30, you guessed it, 690. To practice, why don't we do this? All right, there are an infinite number of solutions, an infinite number on the right, an infinite number on the left. Once you have your initial solutions on each side, you can add 360 degrees, you can subtract it. Same on the left, you can add and subtract. So there's an infinite number of solutions. Let's do a quick practice, and you can pause the video before I reveal the answer. Okay. This one was nice and clean because it said sine of theta is equal to negative 1/2. But, and the sine, when we did inverse sine of negative 1/2 was negative 30 degrees. If it had been something messier, like the inverse sine of, let's say, negative 3/5. That's going to be a wild decimal. So that makes it a little bit harder, maybe even a lot harder, just arithmetically, to do the calculations. But you're still just adding and subtracting 360. I would want to use a calculator for everything else to find that. So yeah, just know that with different fractions, with different decimals, it's not going to always be a nice clean number like negative 30. Okay, so let's do this one. Let's say find all solutions between, let's say, negative 360 actually, let me write it like this. Find all values of theta such that find all values of theta such that theta is between negative 360 and positive 720 degrees. Find all values of theta such that theta is in that window that are solutions to the equation sine of theta, let's say, equals 2/5. All right. You should probably pause the video right now and find all the solutions and then unpause to see the answer. You should pause the video now so that you can work on the problem. Just watching me solve it will not help you in the same way that me going on YouTube and watching somebody play the trombone is not going to make me any better at playing trombone. To learn something, I would need to get my hands dirty and become an active learner and not a passive learner just watching somebody else. Okay, guilt trip over. You have definitely paused the video and done this yourself. All right, here we go. Here's the answer. So first up, we're just doing the inverse sine of 2/5. And there is the answer. So again, if we did inverse sine of the left, inverse sine of the right, we get that theta is approximately equal to, that looks like 2/3. Let me make my handwriting better. All right, so this is going to be 23 point, if I round that, it's going to be 23.6 degrees. Okay. Now, I like storing values on my calculator, and so I'm going to store this for theta. So that is theta. Now when I go to theta, it gives me that value. Okay, so this has a name. Do you remember the name of this, the vocabulary term that we would use for this first answer we get? Starts with a P, it rhymes with principal. That's right, the principal value. Okay, so our principal value is 23.6. Now, where is that on a graph? 23.6 is not in this quadrant or this quadrant. This is quadrant 4, this is quadrant 3. 23.6 is located in quadrant 1. So, quadrant 1. So, let's take a look at 23.6. .6 is going to be, let's see, I want that in red because it's on the right side. 23.6 is going to be, let's see, this is 0 and this is 90. 23.6 is maybe that much. Almost exactly a quarter, actually. So that angle right there, that much rotation, is about 23.6 degrees. Okay, so that's our principal value. We can find other solutions by just adding and subtracting 360. So I'm just going to go on the calculator here, and I'm going to do plus 360, enter, 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 and look at all those values. It's giving me a bunch of solutions. So I'm going to write the first couple. So we have 23.6 degrees about. We have about 383.6 degrees. We have about 743.6, about 1103.6, and it keeps going, dot, dot, dot. It also goes backwards, so I'm going to now subtract 360. There we go, then we're back to where we started. And now we get into negative solutions. So let me put some of these. And it keeps going, dot, 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 dot. Okay, so we have used periodicity to find values on the right side. Now we want to find values on the left side. All right, let's use our graph to find out, again, solutions on the right. I like using red for the right. Now, for solutions on the left, apologies if you are colorblind. Let's do this in blue if you are colorblind. All right, solutions on the left. Let's see, so now we need to use symmetry. So this is that much above the x-axis. How far above the x-axis is that? It's approximately, and that's not a negative, that is an approximately. So it's approximately 23.6 degrees above the x-axis. So I know that my other solution is going to be the same, approximately 23.6 degrees above the x-axis. Let me put that in blue, about the same. Boom. And that is about 23.6 degrees above the x-axis. Now, this one, however, is clockwise, which is negative. When angles go clockwise, that means they're negative. So, what is the angle, the overall angle from here to here? Well, this is 90, 180. Oops, I went too far. How much too far did I go? I need to go back. I need to go back 23.6. So I'm going to start at 180, and I'm going to go back 23.6, which remember I stored as theta. 180 minus 23.6 is 15.4. So 156.4 degrees will be a solution on the left side. So if we have a rotation of 100, about 156.4 degrees. So about 156.4 degrees. And, oh, I should check these to see that all these are solutions. So let's do that. So first, sine of this answer, it's 0.4. And by the way, check out our equation, 2/5, also 0.4. So I'm getting the same exact value. Also, look, check it out. If I do sine of this answer, I also get 0.4. Okay, so let's add 360 a bunch of times. Let's go back up here. There's that 156. And let's add 360 a couple times. And write down those solutions. And let me just check one of those real quick. I'll just check the last one. The sine of that answer, I'm hoping that it's 0.4 because 0.4 is the ratio of 2 to 5. Boom. Yep, the ratio of 2 to 5. So when I do the sine of this 1236.4, it has the same ratio as our principal value. And let me, where was I? Over there. Let's subtract 360. Okay, so I've got some solutions. Let me just write those down real quick. Negative 203.6, and then about negative 563.6. Okay, so, and let me just check those real quick. Sine of that. Oh my gosh, it keeps working out. And I never checked these, so let me just go back and check these real fast. Let's see, 23.6. Let me add 360 a bunch of times. Check this one. Sine of that. Yep. And let me subtract 360 a couple times. Whoops. Minus 360. Let me do the sine of that and see if it checks. Sweet. All of them keep checking, right? All right. Now, we might be done. Dot, 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 dot. It's going to continue. But the problem said find all the values of theta such that theta is in this window from negative 360 to 720. Are all of these solutions between negative 360 and 720? No. So, negative 360 to 720. This one is too big. This one's too big. Negative, so the biggest it can be is 720. That rules out this one too. The smallest it can be is negative 360. So that's too small. That's too small. So what are we left with? We're left with these 6 solutions. These 3 on the right and these 3 on the left.